I actually, I won't push, I won't talk product too much. I'll talk about JavaScript. How many people here write JavaScript or TypeScript? Yeah. How about Java? It's okay. No hate. So, is it important that Bjarne works for Morgan Stanley? I don't know. He used to be a professor at Texas A&M, so that the C++ creator is working for Morgan Stanley, I think means something. C++ is doing great. It's in its fourth life. And I think he was talking about C++ here, but it also applies to JavaScript. There are only two kinds of languages, the ones people complain about and the ones nobody uses. I'll go fast here. This is the latest Stack Overflow developer survey results. It's pretty much JavaScript until you get to mobile, where there's some vendor lock-in that favors Android and Java, which is really just Java. iOS, I don't know what that is. Is that the next two are Objective-C and Swift? I think that's iOS. So there's some double counting here, but JavaScript's in there. And then in this sort of scientific and numerical worlds, JavaScript's numeric types are weak. I'll talk about that later. So it's in there in the middle. Back up there with students. They're teaching Java in a lot of universities. They've been doing it for 15, 17 years, and it's time to stop. And then, JavaScript. This is interesting because this is the other category, and number 2 is actually TypeScript, which is JavaScript with optional warning or tool time type annotations. And Microsoft's done a great job. Luke Hoban, who used to be on the JavaScript standards committee where we worked well with him, and then Andrew Salzberg, of course, designing a type system that was very matched to the JavaScript dynamic types and the object and array sort of ad hoc types that we all kind of know in our heads, this JSON schema types, really. And TypeScript's doing great. And I think it's lined up with a future standard that might have some kind of type annotation syntax. We've tried to carve out against extensions by vendors the colon after the declarator name, so you can hope someday that some redheaded stepchild of TypeScript and Facebook Flow, flowtype.org, will become a standard. It's not for sure this will happen outside of the tools. That's where types are best checked. If you actually had runtime enforcement of the invariants that you're trying to state with types are proofs, you would end up probably having type errors in front of grandma, and grandma don't care. So it's better to have them at warning time. Top Tech and Stack Overflow JavaScript. It wasn't always like this. Some of these talks are bringing a tear to my eye, recalling Comet and DHTML and even Flash, which I actually think should be killed like a zombie that it is. This is my joke web page. My Netscape colleagues made it. They even intentionally leaked some JavaScript source with should have been a script container into the markup. The guy that wrote it worked with me on the engine, and he didn't even know enough JavaScript to do this, so he had to get the QA guy to help him. They gratuitously started Java, which is really slow. Like in the 90s, and even recently I heard from somebody at Palantir who worked at Palantir Government before it became Gotham or something, and they had this lockdown government PC with an old version of Java, and this was before Palantir switched from Java Swing to JavaScript front-end APIs. They would start up their app, and they would go away for 30 minutes before it actually started. So my homepage would load, and it would start Java, which was the ultimate insult. But some things in the 90s looked kind of like that. I will talk about Brave. I've got a new browser. I think it's time to shake up the browser in a big way. The big idea here is actually not about enterprise. It's about people owning their own data. And the only way you can do that is to block surveillance and tracking and third-party scripts aggressively. Otherwise, your data gets exfiltrated and you're arbitraged into the ground. So try Brave. It's out. It's going to be 1.0 in about a month. It is very fast because it blocks ads by default and trackers, and we make sites work. We get rid of that stupid Forbes lightbox of doom with the little counter when you go to Forbes. We hack around Wired's ad blocker. It's trivial. you'll like it. It's a lot faster and it's more integrated, and we make things work for you because it's your experience, it's your data. And protecting your data has lots of economic upside we hope to get to down the road. Right now, what we enable is automatic, decision fatigue-free micro donations. If you want to fund your user wallet in Brave, you can do that, and then there's sort of a chart beats algorithm built in that will automatically figure out what sites to support. You can go to your settings and turn off the ones you don't want to support. We are curating a list of platforms you shouldn't support because they're owned by rich landlords like Google, YouTube, and we hope someday to pay the tenants, that's the users who generate content in YouTube accounts, which is a future thing we'll be working on. But the topic here is about enterprise because we know from lots of history of security attacks and vulnerabilities, Heartbleed, man in the middle, that there is something important at stake that was defended insecurely in the 90s with SSL version 1, secure socket layer, version 2, version 3. TLS is getting better, and there's always ways to attack things. But what browsers represent is this magic sort of carpet, or maybe a wormhole from the great beyond where the old ones, the evil Lovecraftian entities live. And they send malware through secure connections into your potentially regulated institution. I just met with one of the big ones, and they're smart. They virtualize everything, but there's still risks, right? There's still virtual machine sandbox escapes. There are multiple-step, multi-layer attacks. So the browser is still this magic endpoint where TLS terminates. And if you don't secure your browser by blocking things aggressively, you are simply quantitatively more at risk. So we're seeing what Brave can do for these enterprises and others like them, like Pixar and Sony, to pick on some unregulated enterprises. Another slide on Brave. This is the ghostery tracking graph on the left. It's a D3 physics graph. This is TMZ, which is just a nightmare. I think they started, this is before they added header bidding, which is some scam of multiple sort of ad tech header bidders being integrated. And they're just jamming your network with script loads and extra calls and waterfalls and nonsense, taking your data out where you lose leverage over it and slowing down your experience, turning the radio on if you have a mobile device too much, draining your battery. With Brave, it looks like the right. They're just the domain shards and virtual first-party sites, and we sometimes have to let Google Analytics through, though we generally don't. In a regulated enterprise, you might have old browsers, let's call them that. Some of them are evergreen, which is good, but the vendors don't really care about the enterprise so much as they care about consumers and advertising. And so there is this risk through secure connections, which are rising. Let's Encrypt is making certificates free. I think it's like 40% of the web or more. I think it's heading toward 50 is HTTPS. To defend against that, you really need to be in the browser. You can't take apart the connection and man-in-the-middle attack it. You'll be caught by the browsers that do certificate transparency and other checking. And it's a bad idea because doing man-in-the-middle opens attack surface. So what are you going to do? Well, one idea is you just have a new browser that is defensive by default. It blocks scripts aggressively, and you bounce people to that browser from the old browsers, except for the legacy apps that need the old browser. I've heard recently that somebody has like a specimen from the bygone era. They have IE7 running a virtual machine, running some .NET boondoggle from 10 years ago that they still need. Eventually, these things will die. The previous speaker spoke about needing HTML4. You don't need HTML3.2. It's dead. Early versions of table layout, CSS table layout, even some things in JavaScript have changed incompatibly since the 90s. The only way to run things from the very beginning of the web archive is in a virtual machine using Jamie Zawinski's nostalgia browsers, Netscape 0.9 and Netscape 2. So this is something we're pursuing. We'll see how it goes for Brave. I think the general theme ought to be that you have a very secure browser that's acting in your interests, not in anybody else's, not in the network superpowers, certainly, and it's blocking things and it's securing against real threats that are out there, malvertisement. When I did JavaScript in 10 days in May, it was the core engine, and then I spent the rest of the summer embedding it in Netscape 2, and it looked kind of like this, except they didn't have audio and video elements, of course. They did have plugins, those were in Netscape 1.1, and they were considered a stopgap. And Flash, more than Java, which was also a plugin and nothing more, did have a good run, and it innovated faster and it got wide distribution, I think 90% or more, depending on who was telling you. But I tried partnering with Macromedia, then Adobe, to restart JavaScript standards, And we didn't quite succeed, but that was part of a larger effort, which took a long time. JavaScript's 21. It's out of the house now. It can go drink on its own, and you know, it's the disowned millennial. This is a chart by Kangax that shows the progress implementing the latest ES 2016, which is like ES 7 if you use same numbering. And it's actually getting good. It's getting in all the evergreen browsers. It's much evolved. It took a lot of work to do this. I remember meeting Douglas Crockford in 2001, I believe, in the fall at Netscape, and he kind of looked at me like the proverbial Dutch uncle, a term from the Dutch-English wars when the sailors would complain about being told how to do their sailing jobs by the Dutch. He said, well, you've got to fix JavaScript. Go get the standards body to fix those mistakes. And I said, be right back. I'll restart the browser market first. And I went and did Firefox, and we used Firefox to restart the ECMA standards body, which had been totally shut down by the IE monopoly, been mothballed in 2003. An offshoot of early JavaScript 2 work from somebody at Netscape I'd given the keys to the kingdom to actually made it into the Flash player as ActionScript 3. Anybody here use ActionScript 3? Yeah. We tried unifying that as ES4. It didn't work. But we did create the modern era of Harmony where we have ES6. So a modern browser is actually what I think Sun wanted to do when they were assuming that Netscape would be their distribution vector for the Sun JVM in 1995. Plan didn't work. The JVM wasn't designed to be part of a browser or have a lot of good APIs, but we finally evolved through competitive pressure and lots of work to a system that looks more like this, and it has a lot of APIs. Now, I do want to talk about something that's coming that I think is interesting to fintech people, but just what we have today is very good. You can write Node.js in the server, you can write Node.js in Electron, you can write JS that you compile essentially to work in the browser. The ES6 module system is coming along. We had a very good meeting at Netflix last week where we worked on a harmonious reconciliation of node concerns and ES6 module design. And so things are looking pretty good. And the security policy has been beaten on the forge of reality against many threats. You know, the security is never done. This is a consequence of the incompleteness theorem of Gödel or the undecidability problem. But you've got to keep patching your code. You've got to keep testing it. You've got to keep fuzz testing it and have bug bounties, pwn-to-own contests. If you do that, you will be more secure than if you don't. And that's all we really know. Because there's always some new place to attack that you didn't defend because you didn't have enough money, and you can't defend everywhere. So we're going to make it even more challenging for security by adding WebAssembly, but it builds on the same safety properties that we have in JavaScript. It builds on the same origin policy and other sandboxing sort of object capability model. WebAssembly is a second skin for JavaScript. It's another syntax. It's more efficient. And that's why we're adding it, because loading JavaScript, even if you gzip it, you have to unzip it to parse it. Got those fat 8-letter function keywords. I was influenced by awk. We can do better. And that means that if you get the second syntax that's faster to load, it can have all the same APIs as JavaScript. It can be in the same shared world of a single-page application or a service worker. It can be sharing references. You can have code mixing, and people do. This is coming along in all the browsers. It's being prototyped. There's still some design decisions open, but it's going to be in, I think, mainline in Q1 next year. It might even be in the Nightly's Canaries late this year. WebAssembly is coming, and it's because of work we did on JavaScript to prove that one VM can rule them all. And this is different from plugins. Plugins inevitably add their own VM, like the ActionScript VM, the Java VM, and then you have two VMs. Now you've got two problems. They cannot share the DOM or heaps without potentially making uncollectible cycles, garbage cycles. And then you need a super GC, a cycle collector, or you need to make them all use one garbage collector, which is really what you want. You want one VM. The .NET architecture got this right, and it's a polyglot. Java VM has evolved to be a polyglot VM. Browser is evolving that way, and WebAssembly is the key. So it's a new standard. It's in W3C. Getting all four of the major browser vendors to collaborate took a lot of work. At Mozilla, we did this by we flipped Microsoft, basically. We were like a good cop, and Microsoft was realizing they had to up their game against Chrome, and they saw that we had made JavaScript super fast in a certain dialect called WASM.js, and they came on board. And that, I think, eventually caused interest from Apple. They're very careful not to say when they want to do something. They're like the starlet who arrives at the party at midnight when the booze is gone and says, now I'm here, start the party. Google as Google does, they have many different tentacles, and the left tentacle didn't know what the middle tentacle was doing. They had a portable native client project, which was just another plugin. It was doing some clever things for safety, but it was never going to become a standard. And the V8 team had a fight with the Pinnacle team, and there was, I heard, blood on the ground. And at the end, the V8 team won, and WebAssembly had 4 vendors all cooperating on it. It's a compact, portable binary format, as I say. It's fast to load. There's also a secondary outcome, which is that you can read in your developer tools a sort of text format. They're still debating what it should be. I hope it looks like Lisp. There is one proposal where it's S expressions. This would pay back the management at Netscape that made me make JavaScript look like Java when I was originally lured there to make it look like Scheme, which is Lisp. And WebAssembly has many other natures. You could think about it as a compiler target, a virtual instruction set architecture, another JavaScript feature because you can mix code, and an evolution of WASM.js. I'm going to go fast here. It's not a programming language you write by hand. WebAssembly is a bit code. You won't be able to grok it. You don't even want to write those S expressions. You want to compile from another language. Initially C, C++. Pretty soon any LLVM language, Clang on macOS, you can compile. Eventually dynamic languages, even Java. It has modern properties like a better bytecode should. It's evolvable without breaking compatibility or tying your shoelaces together so you make bad design decisions because of bytecode compatibility, which Java did. It has types, which JavaScript doesn't, at least not explicitly. And it's safe. It's self-verifying. You could read a GIF of the Mona Lisa as WebAssembly, and you would get either a syntax error or something that ran. It might have been a nonsense program, but it would not pwn your machine. People want to know what it looks like. Again, it's bits, so I can't really show you, but it has notation like i32.add here, which maps to the x86 add instruction, the ARM add instruction. There's a pretty good correspondence with safe low-level instructions. When you do memory accesses, there has to be a check. The check can be 0 overhead on 64-bit architectures through sparse virtual memory mapping techniques, and it can be hoisted and commoned because WebAssembly is very optimizable. It lends itself to optimization techniques like static single assignment. So it's a safe format, very efficient, about as safe as you can be. It's as safe and fast as portable native client was in good days at Google, but on the same VM as JavaScript. And the load time is the real motivator because it's much more concise, but also cache effects, memory effects. You get predictable performance. With JavaScript, if you use dynamic types, sometimes you fall off a performance cliff due to the just-in-time compiler having to re-speculate on new types that evolved in a different phase of the program, and so you have a jank or a little slowness. Also, the garbage collector can run. Garbage collection is not free. It uses twice the space and maybe twice the time, or can use less time, but then maybe more space. There's a real trade-off there. But WebAssembly can use fixed memory layout. It can do C-like allocation. It can be very fast. We see it being used in its WASM.js form already. People are building modules. I think Kim.com has some kind of crypto library cross-compiled from JavaScript in his latest mega upload too. And there's a lot of APIs you can use, like WebRTC's Get User Media. I know someone I met who's at OpenAI. He's doing, instead of Python supervising TensorFlow, nested neural nets, deep learning neural nets, he's using JavaScript in browser swarms. He's even doing some machine learning in the browser using JavaScript. It's fast enough. And he uses a lot of browsers. I don't know how he gets them. I hope he doesn't pwn them. And games and simulations. Those are really the existing proof points I'll show you. WASM.js is how we started this. We did this fast subset of JavaScript. We didn't quite know it was there, though I copied a lot of C and Java features like bitwise operators, and it meant that there was a very fast subset inside JavaScript. It was like finding the statue in the block of marble. It was carving nature at its joint, as Plato says. And Edge and Firefox actually optimized WASM.js very fast. I think the other browsers want to just do WebAssembly, so they're going to wait for WebAssembly to be finalized into the end of the year. Slackers. They really should get on it. And how do you compile it? Well, how many people here write C or C++ and run compilers? Not as many. It's exciting. You should try it. except, it's memory unsafe if you're writing a C program and compiling it to native code. If you're doing WebAssembly, it will be safe. There's an EMCC command you can use to write ASM.js today. If you use the JavaScript, this looks a little funky. There's a use ASM hint. You can ignore it. Some engines do. There are little cast operators like the vertical bar 0, basically forcing things to be integers, 32-bit integers instead of double precision floating point numbers. But otherwise, it's just JavaScript, and it runs faster or slower depending on the engine. Craziness, when you write native code, some of you want threads. How many write C++ or C and use threads? Yes, okay. JavaScript is getting threads. I said in 2007 it would get threads over my dead body, and I'm still alive. So I think what's happened here is we've made a compromise where WebAssembly was going to have threads, and we realized that you couldn't hide them from JavaScript, but if they were opt-in, it would be acceptable. Most programmers won't use them. It won't break invariants outside of the module that uses threads, we hope. But I think we're getting threads. I hope I survive. And we have to keep evolving. The WebAssembly on the right and the ASM.js on the left correspond, but notice there's something called emulate there, which is that we don't have 64-bit integers in JavaScript. How many of you do sort of large fintech quantities in math in your programs? And figures like national debt or GDP, things like that. Yeah, you run out of precision in IEEE double at some point. It's not really great, especially if you're doing pennies. So I've been proposing this, and I've been too busy with Brave as a startup, but I think I'm going to get back to it because we really should put in at least 64-bit integers. But I have a proposal, or two proposals really, to put in arbitrary numeric types. Some of them will be built in. Some of them you can write yourself, like complex numbers if you want. int64, uint64, float32, those are obvious because they're in typed arrays from WebGL, which is part of the ASM.js memory model, part of how you make the GPU go fast. Big integer, I'm not going to call it that, it's too long a word, and Java really messed it up by not giving it operators. Decimal, IBM loved decimal. For years they wanted it in the JavaScript standards. It didn't happen, but some people like decimal. Does anyone here use any kind of decimal, sort of big decimal in Java, say? Has anyone ever used that? I don't know. Did it work out for you? Kind. There's a great blog post from Cameron Purdy where he talks about how they really messed up because they didn't give it operators, so people forget to use it. And the first comment is somebody who worked on Wall Street at the time, and he said, yeah, I was just doing code review, and we found somebody had big decimal A and big decimal B, and they wanted to add them, so they said A dot number value plus sign B dot number value, and they lost all their precision right there. They went back to double in Java. You need operators, so part of what I'm proposing does allow you to extend some of the operators. We don't let you extend not equal or not bang, because that would allow you to violate important equivalences like De Morgan's theorems. This is coming, and I think it's important, but I'll take a poll. How many of you don't care about bigger number types in JavaScript? And you're just fine the way things are? Nobody. How many of you want bigger number types in JavaScript? That's good. I'll take that back to the committee. They're always doubting. They're always like, oh, people don't care. No one needs it. So, the ultimate angst is, will WebAssembly replace JavaScript? I don't think so. There's just too much momentum. Node.js is huge. JavaScript has to be implemented by browsers. It's obligate, not facultative, as the biologists would say. You need JavaScript to be there to be fast for as long as we have raw JS source on the web, which is going to be a very long time. And if WebAssembly is used as a target for compiling a program and you want to script it, you're probably going to want JavaScript instead of a guest scripting language, because even when WebAssembly is mature enough to support garbage collection, dynamic objects, types, JavaScript is going to be better. So let me do a demo or two. This is just to show how ASM.js got really fast. These are fun. This is called Dead Trigger 2. It's on the Unity engine. Both Unity and Epic Games Unreal Engine are cross-compiled to ASM.js. There are a lot of Unity games on Facebook. I'll show you one later. This is a zombie game. It's a little gory. I'll use my sentry chickens to take care of the zombies. These are chickens with machine guns on their backs. And they'll take care of your zombie problems for you. I can look for treasure. There's a pig there, a golden pig. See, the zombies don't even get to me. My loyal chickens get them first. Thank you, chickens. Unfortunately, the machine guns overheat sometimes and blow up. It's really sad, but you can respawn. Oops, he's coming at me. Okay. You notice the zombies are carrying fat stacks of cash. I don't know why that is. Maybe they're fintech zombies. All right. And this is another game. There's tons of these on Facebook now. This is an actual thing. People cross-compile the Unity 5 engine using the tool, and they get games like Ski Safari, which is a lot of fun. Yeah, I know how to play this. Thank you. I confess I have played this game. It's a lot of fun. There's basically a 2D, sort of pseudo 3D skiing game. There are Yetis. And it's not using all the 3D power of the Unity engine, but it's running in real time, and it's a fun game, and I'm actually pretty good at it. I want to find a Yeti, and then I'll quit. But there's penguins too. Oh, and the avalanche is coming, so you got to keep going, or else you're gonna. Damn it. There we go. Got a penguin. They speed you up. They shield you from rocks, and they get blown up when you hit a rock. Oh, ouch. My microphone's kind of in the way here. Let me see what I'm doing. No. All right. I have mad skills, I promise. Oh! They're just failing me. Okay, now I can see what I'm doing. Yeah, I'm really not a great gamer. At Netscape, we used to play Quake, and the 20-somethings would machine gun me to pieces and laugh. Where's a Yeti? There's one in the background running on the hill. There he is. Oh, I passed him. Damn it. There'll be another one. And you can flip. And there's another Yeti. Oh, I'm passing him too. When you catch a Yeti, you get on their back, and you sort of can make them into a sled. You can rock it along. All right, it's gold. There he is. It kind of groans, yeah. It kind of wails up a little bit. It sounds like Scooby-Doo. Got my penguin back. Anyway, this goes on and on. The mountain never ends. Oh yeah, I'm surfing on the clouds there. There's a Yeti. All right. I got an eagle. Well, the eagle doesn't last. He'll drop you at an awkward moment. Yeah, the Yeti's got some complaints. There are snowmobiles. It gets a lot of fun. You can do flip. Oh, there he is. I got him back. No, I didn't. Oh. See, now that I'm looking around the microphone, I'm doing better. Anyway, it's because of all this kind of mad optimization, which indeed, as the previous speaker said, makes us faster than Windows Presentation Foundation, which was supposed to bury JavaScript, that I usually end my talks by saying, always bet on JS. Thank you very much.